Hi everyone. Today I'm going to talk to you about a topic that I introduced a couple of months ago, but I wanted to reiterate it right now for a couple of reasons. First of all, because people have computer science final exams and projects coming up, I think it's particularly relevant at this time of year. And also, I understand that sometimes people like to see a video format rather than just a reading through a document. So I thought this video might also help some of you guys who are more visual learners. So let's go ahead and get started. We're talking about the 6 steps that you can take to solving a programming problem. And in this video, we're just going to give an overview and explanation of the steps. So how is this information useful? So this 6-step process, the first thing it does is it helps you to organize your thinking. So I am a tutor, and one of the topics I help with is computer science. A lot of times it's usually Java programming. One of the problems I see with students is a lot of times they don't take time to figure out an organized approach when they have a practice problem that they have to do. So this process is something that I recommend to help them uh, get that process down on paper and organized. It also helps you to break down the problem into manageable pieces. So rather than getting overwhelmed and feeling like you don't know how to tackle the problem, if you can break it down and do it a step at a time, it becomes a lot easier and you become a lot more confident, hopefully, in your abilities. The other thing that it does is it helps you to make sure that you clarify your requirements and really understand what you're trying to accomplish. Sometimes I've had students who've done practice problems, and upon looking at their solution, they've left out a lot of really important elements. And by taking the time to understand and clarify what you're supposed to do, you will help yourself in getting a lot more of these problems right. So this process is particularly useful for the AP Computer Science exam free response questions. If you have any lab assignments where you have to do programming problems or turn in code, this helps with that. And also, if you're just working on a project of your own, or if you're doing this as a job, it helps you to figure out how to do programming tasks that you need to do. And we know that sometimes you might want to accomplish something, but you might not always be able to find a step-by-step tutorial for it. So I want you to be able to figure out how to solve problems. Okay, so let's talk about what the 6 steps are. The first step is to understand the problem statement. Then you want to identify the expected behavior. Next, you want to identify your supporting information. Then you want to work on mapping your supporting information to the expected behavior. Once you've done that, you assemble all of the pieces and the information that you've put together into a solution, and then you test and verify your solution. So we're going to go over each of these steps in more detail right now. So understanding the problem statement. So what do we mean by that? So you need to figure out what is the problem asking you to do. If you're working on your own projects and you don't have a written problem statement, in this case you need to figure out what are you trying to accomplish. What are the expected inputs and outputs of this problem? Do you have any particular test cases that the problem statement gives you? And that goes back to figuring out what the expected inputs and outputs are. If you're doing this on your own, you're doing a project of your own, then you might have to come up with some of the test cases by yourself. If you're working on a job or doing a project for a client, then they'll probably give you some sort of requirements. Are there any additional or extreme test cases, border cases, that you should consider? So, for example, if you're doing some sort of a program that deals with numbers, usually you might think, okay, well, just whole numbers, one, two, three, four integers. So, do you need to look at negative numbers? Are those valid cases? Do you need to look at really high numbers, really low numbers, things like that? So at this point, I think it's helpful to make a checklist or a bulleted list or something of the requirements. And if you're taking a test, for instance, you want to just quickly write something like this out. Okay. So the next step is we want to identify the expected behavior. And by that, I'm asking you to figure out what are the steps you need to take to get from the given input to the expected output. So this is sort of like your algorithm. And an algorithm is a series of steps or a recipe for how you're going to solve the problem. And this is very important because you want to put some thought into this. A lot of times I think students make it more difficult for themselves because they don't take the time to do this step, and then they're just kind of throwing code at the wall and seeing what sticks. You might want to do a flow chart in addition to just or listing the steps out in writing. So, that's also like a visual way to see what needs to happen. So then you want to figure out what your supporting information is. So what do we mean by supporting information? So this could be a variety of things. So in addition to the overall problem requirements, are there additional restraints or stipulations or information that the problem statement gives you? For example, are there suggestions about using certain methods or certain approaches, things like that? Do they require that you use certain approaches? That might be an extra requirement or stipulation that you have to consider. Just by reading the problem statement, if the problem is asking you to write a method, for instance, are there any return types that you have to have that your method has to adhere to? Does it tell you what arguments you need to pass to your method? Does it give you any specifications about the method name or method signature or any other specifications? One way to determine this is to see if the problem statement gives you any examples of code usage. So by looking at how the code is used, it can help you to see, okay, well, what kind of return type is this problem expecting? Um, an example will also show you if any arguments are being passed in, that sort of thing. In addition to what the problem statement is giving you, what information do you already know that can be helpful to you? So, once you break this problem down into steps, what methods or libraries or classes or approaches do you know of that might be helpful for solving the problem? And sometimes you're not always going to know at the start how to solve the problem. So then you want to start thinking about what additional questions do you have that you need to figure out. Or do you need to do research on, for instance, how to get user input if that's one of the requirements? If you don't know, you might start writing out questions. And as you research and find answers to these questions, you'll add that to your supporting information. So it's kind of like having, if the problem statement is the puzzle, your supporting information is kind of like the pieces that you're dumping out of the box and that you're going to then put together. Okay. So the next step, once you have your supporting information, you're going to map it to the behavior, to the steps that you've put together. So for each step in your algorithm, which piece of supporting information is going to help you to accomplish that step. So you might even want to do maybe like a table or something like that to map the steps and then put the relevant supporting information in so that you have it in a really organized visual fashion. Okay? So once you've done the previous four steps, the next step is to assemble the pieces into a solution. So you're going to use all of that information to write out your code basically. And hopefully, if you've done the preceding four steps, you should have a lot easier time with this step, and things should fall more into place. Okay, so the last step. Once you've assembled your solution, you need to test and verify the solution. So a good place to start is to make sure that your solution correctly satisfies the test cases that you put together. So the test cases that the problem statement gave you, and any additional test cases that you came up with on your own. So if you are doing a lab or something of that nature, then a good way to verify this is to actually type the code into your development environment, compile it and run it, and make sure that it works, passing in all of the test cases. If you're on a written test or exam, you might not be able to do that. So you kind of want to do maybe a sanity check of going through each step and you writing out by hand at each step what the results are. And you might want to do it that way. Another big thing that you want to do is make sure that you meet all the requirements on your checklist. So, like I said, a lot of times I've seen students who have come up with a solution, but they've missed some very important requirements that the problem statement stipulated. And if they had gone through the first step where, we said to understand and list out all of the requirements, they would have been able to go back and verify, okay, did I do everything the problem asked me to do? Okay, so if you have errors or you see problems, and this is particularly obvious when you try to run the code on the computer. If that's the case, if you're running this on the computer, first of all, look to see if you get any error messages. And a lot of times those will help you figure out where the problem went wrong. If you're not having any luck with the error messages, or if you don't get any error messages but the input and the output were incorrect, then figure out, do you see any patterns in your actual results versus the expected results? So, for instance, maybe if you're doing some sort of a calculator problem where you're writing a calculator, are the addition calculations, are they off by a certain amount every time? Uh, do you see any patterns or anything like that? Those that can help you figure out what went wrong in your problem too. So at this point, you're also going to just want to retrace your steps and go through and repeat this process as necessary. Maybe adding to and updating your supporting information. So that is it for the explanation of the six-step process. So keep an eye on the comments down below, or the video description down below. There's going to be a video link to an actual example using this process. All right? So please let me know if you have any questions. I hope this was helpful, and keep an eye out for the next video. Thanks.